I'm gonna sit over here. Okay. Next up is Don Brady. He's gonna be talking to us about a feature that's been long in the works. I think I remember 2 years ago. 3 years ago. 3 years ago, the hackathon for this conference was also in Delphix, and in that very room, I remember there was Don and a whole bunch of other folks who are here today talking about how we're going to do allocation classes and how they're going to redesign the whole thing. And then Don went and did it, implemented all that, and was finally just integrated to ZOL Friday? On Friday. So Don's here to kind of give a recap of that project and I guess what it took to get here.
Yeah.
So thanks.
Okay. Full allocation class is also known as 5182. If you were following the pull request that Matt mentioned. So yesterday, I think there was several Q&As that mentioned allocation classes. Was anybody out there like thinking like, what's an allocation class? Anybody like kind of lost in terms of, yeah, okay, good. This talk is for you. So I'm going to go, this is lightning talk. I'm going to go pretty fast, but I'm going to try to talk about, cover what they are, how you can use them, why did it take so long, and why doesn't it support, no, wait, that's not right. How can you help me get support for whatever's missing, and then, sort of what's next. So this initially was a feature, and DRAID, the previous talk, it was a sub-feature of DRAID. So we had DRAID, we had 16 meg blocks. This was at Intel for an Aurora supercomputer. And we were anticipating having a workload that was such that we'd have like these checkpoints coming in 16 megabyte streams. And then we had this metadata. And so the disparity between those two was so great that we had to separate them. And so that's where this feature came into existence. I think even the pull request said metadata allocation classes. It has morphed into a more generic allocation classes, but that's sort of the essence of why we started doing this. And as Matt mentioned, there was an early pitch to the community at a ZFS hackathon, and then we went from this metadata only kind of very narrow thing to more generic, hey, let's have a bunch of class variants. You can have MOS data, you can sort of separate it out, you can have sort of all these combinations of that. Additionally, there was refinements along the way. We decided to add small blocks. Someone wants me to speak up. Is that better? It's harder, but okay. Along the way, there were some refinements. We added support for small blocks. Again, tied to DRAID. We added some stats. They were pretty cool, but in the end, I'll talk about it later. We just couldn't afford them. And then there was special considerations for people used in the future. So Matt mentioned, yay, landed last week. If you can, it was 2016, in September, 2 years ago, where I opened the pull request. And thanks to the community, lots of good comments, lots of good feedback. So how many here are familiar with a slog and what that is? Okay. Yeah, so the slog in essence is the log data. You want to put that into sort of a special tier, most likely an SSD. Highly transient data, sensitive to the latency, IOPS, and so we have that convention in ZFS today. When you create your pull, when you're adding the log device, you just put log in front of it, and then we set it up to be separate. In the same way, these allocation classes are a separate tier. It's like a separate VDEV. We put those together in groups into a class, and so data is going down a different path. We used the per VDEVs app. You may have heard people reference that. Those are like properties associated with the VDEV. We use that to store, in essence, the bias, what we're putting in there. And we also activate a feature. We encapsulate this into a feature flag. And the reason being is if you, for example, have an expensive or sort of smallish tier, you're putting your metadata in there, you don't want someone to take that pull to an older version and then fill it up with file data. It's like not very good use of that resource. So if you take it to an older version, you can mount it read-only and get your data off, but we won't let you write to the data. Hey, another reference to George's I/O pipeline. So yesterday, George talked about the pipeline, and in the pipeline, there is it's sort of late binding allocations for ZFS. So basically, at the end, we need to find a space for the thing, and it calls down into the metasub layer using this function called metasub alloc. And today, it was just, hey, there's only one class. Get the class, pass it down. I'm surprised the interface even had a class, but it was for the ZIL, basically. When we added the slog, we added the slot for the metasub class. With allocation classes, we now have this new function called SPA preferred class, and that will take input from the block, such as the type, the level, things that'll help it decide, is it a candidate for a different class than normal. So that's essentially sort of how it comes into play in the pipeline. As far as administration, it's pretty simple syntax. Like most of ZFS, all you do, similar to the slog, is you add the bias in front of the tier or the VDEV, top level VDEV you're creating. For example, special, you can add it at full create, or you can add it later using the VDEV add. Here's an example of what it looks like when you do a ZPL status. The other classes will be listed in a similar way like the logs were afterwards. In this case, we have a dedupe tier, we have a special tier on NVMe. And similarly, for ZPL list and ZPL iostat, if you do a -v, it'll call out those VDEVs. So it's useful if you want to see, like, is the bandwidth of my special class like constraining me? You can sort of see those that information. For coverage, we added to Z-test. Well, by default, Z-test, like everybody else, will 50% of the time toss a coin. We're going to do some special classes. But to have more control over that, I introduced a new flag, and I'm welcome to feedback here. I just did -d for class, and then you can say special equals on, special equals off if you don't want to have the interference, and by default it does special equals random, and that helps us exercise basically adding them. Another sort of tidbit is that there are no files or zvols in Z-test. We use a special block type. I can't remember off the top of my head. It's like the comment says, like, for testing only. But so we're not using files, but we changed the macro that's used by that small preferred class I referred to say, like, is it a file block or this like special block that the Z-test using, so we get the code coverage. Likewise, in the test suite, we added a suite of tests called alloc classes that will go through, create pools, do various testing, device removal, things like that. So you get coverage for the feature in the context of other things. ZDB, there's a few places where you can see it. If you do the -m to list the metaslabs, we'll augment the metaslab with the bias for that particular class. The -b, you can see in this example down on the slide, you can see the special class. It's called out, how much space you're using. And then the -s, similar to the ZPL status, you'll see the thing broken out in its class, basically. So you'll see it'll in this case, I don't think it sorts them, but it'll put a tag on the VDEV when you list it out to see. And that's useful in the Z-test. The Z-test will do -s's as it goes through, so you can sort of see, hey, did I get any allocation classes? I can see that. Did I go backwards? So as I mentioned, I kind of alluded to earlier, we have this provision for small blocks in the special class. It's per data set, so you can actually on a data set say, I want up to this amount of small blocks, and that's like say 32K to go into the special class, and that's really more for like DRAID. DRAID can be provisioned to have some of the metaslabs be mirrored versus being this really wide stripe. And so it would be bad to put small 4K file into this 256K stripe. So in those cases, we allow you to provision it so that you can put small blocks into those mirror tiers and get better spatial efficiency. By default, it's off. So it's a very kind of specific opt-in use case. And so, why did it take so long? And so you can sort of share in my context. I created a home game of Chutes and Ladders, and it has all the chutes that we encountered along the way and a few of the ladders. So,
Do you want to spend your time playing the game?
yeah, I'm gonna have it out there. It's actually, you can play it, and that came to mind when I was talking about it. And my manager Seb, who might be on the video stream, said, "Why don't you make a game board?" And so I did, and it felt like that. It's like I would be making huge progress. I'm thinking this thing is landing next month, and then someone puts back device removal. It's like, oh man. And so,
did you hit a lot of ladders?
yeah, there's another, and so there are these big features that sort of intersect meta slabs is where I felt the pain. Primarily, it's because someone will call, hey, I need to get the class, so I'm just going to call spa normal class. It's like, well, there's multiple classes. You can't just assume that. And so throttling, parallel allocations, device removal, those types of places. I had to go back and figure out like what's the appropriate context to get the class. There is a new field in the ZIO structure that has the class where appropriate. So, and then I mentioned the broken block stats, and that one was really kind of frustrating to me because you think ZFS is copy on write, and a block pointer is, I assume, immutable, right? You have a block pointer; it's not going to change. So on Outlook, I take that block pointer, devise which bin to put the stats in, and on free, I undo that. Well, it turns out it's not immutable because if you have dedupe will actually dedupe that block and later say, here, it'll just make up a block pointer and make up like the level's always 0 and things like that. So the counting was getting off with dedupe. And then with gang blocks, it further made it harder because the gang blocks tracking like what's the actual block here and things like that. So the code had more exceptions than actual code. It was just getting unwieldy. So I ended up in the end to actually mine the feature, have to take that out. So I was a little bit sad because of all the time I invested. I think it's better because the maintenance cost, like maintaining something like that, would have been too high. I think we would have been breaking it. And then, of course, traditional project management, feature creep. Hey, let's put small blocks in there. And we had this whole feature called segregation where with D-RAID, you can actually divvy up the meta slabs that way rather than like what we do now, just basically say it's a separate VDEV. And anyway, so then we simplified. We talked about having all that stuff. We simplified all these things along the way. We're just taking the time. But there was some ladders. We got great feedback and help with the testing, and it helped to have actual consumers using it and saying, "Hey, it would be better if it did this." The initial work was done under a contract, so there was a contract deadline to get it to sort of a critical mass, and that helped. And like I just mentioned, removing the sort of non-essential features was kind of the final thing that let me crawl out of the whole of the features. So for the future, or if you see something missing, how can we make this thing better? This is ported, or this is landed in ZFS on Linux, but I'd like to see it ported to FreeBSD and the other platforms. And it should be a simple port. It's all in the Metaslab layer, essentially. You shouldn't have any platform dependencies. D-RAID integration. Once we get D-RAID set kind of back on its feet, we have to integrate this, make sure it works. The small blocks, being able to add a special class that goes to a virtual, this mirrored thing, basically, like a spare. I'm sorry, People are having trouble hearing me. And embedded slog is a concept. It's similar to this, but instead it's just basically having a separate metaslab for each one of your top level VDAs that we can put slog data in. So it can leverage some of this work. And in the same way, having custom pluggable allocators that are more in line with what kind of the workings that you do. That would fit nicely with this. The VDAV properties would be another way to sort of do some administration on this. Right now, like I mentioned, you can just set it at create. You can't change it. You can't remove it. So it's possible that we can maybe let you augment the policies with VDAV properties. And then some sort of policy refinements you may want to have, like for large files, don't put my small blocks in there. Other type of policies, maybe even some sort of limited QoS, or if you pay me more money, I'll put you in the special class, that kind of thing. That's pretty much it. I have to thank Matt for his help over the last 3 years of guidance, feedback, and patience. And likewise with Brian prodding me to finally land this thing and not hold up the .a tag any longer. So that's it. I'm going to have it. It's available online in the tag, but I have a version of it running if you want to come and play with it. I'll have it on my laptop. So that's it. Any questions?
So there's 3 different classes right there?
Yes. There is what we call the special class, which is metadata, but you can do refinements on that. You can say, like, I don't want any of your indirect blocks. I don't want any DDTs, things like that. Those are all tunables. And then there's the dedupe, which is very specific. So you can put your dedupe table in a tier.
Right. So there's only 2 there.
Well, and then log. Log was
right.
already there, and so
normal.
and then normal. Yeah. So there's 4.
Okay. So
There's 2 new ones.
right.
There's 2 new ones, and there was existing ones, of course.
Okay. Because I was wondering if it made more sense to just have special and have like the VDAV properties to control what goes on it, but it sounds like we're already pretty much there.
You might want to have both, though. Yeah, I suppose. Yeah, and those are things we
Right.
can
Like
refine
you said,
because in the implementation, basically, when you instantiate a VDAV, we need a bias, and
Yeah.
so how we get that can change over time.
So yeah, it sounds like it's better than I thought it was as far as we just declare this as a special VDAV and then we'll be able to adjust the policy of what gets stored there.
Yes. Yeah, we're doing tunables now because it's like we don't know. We're kind of guessing. So.
So I saw in your ZipFool list you had like this section for smoke.
Yeah, that was like never edit your slides last minute because the name of the pool was smoke, and I thought that's kind of it's smoke test. But so I renamed the pool demo, and then I didn't look further ahead.
Okay, it wasn't the name of the class.
No. No, that's the name of the pool that I edited and messed up.
Well, I think this may be one of the only major features to be implemented across multiple companies. So those of you who might not know, Don started this project and implemented most of it when you were at Intel.
Yes.
Right? And then completed, under the contract that you said, and then you joined Delphix a year or so ago.
Over a year ago, yeah.
So I'd like to thank Delphix and Intel for both, working together to sponsor this work, for Don to complete it, even after changing his employment arrangements and whatnot. So
yeah, and it was actually done under a government contract too. So to some small degree, you all contributed. If you pay taxes.
thanks, Don.